Well, let's talk about solving systems of equations, but they're not linear equations. We're going to do similar type techniques that we talked about back at the beginning of the chapter. So we'll use some elimination, we'll use some substitution, whichever one you think is more convenient. We just have to be a little bit careful when we're solving because we'll have multiple solutions sometimes or no solutions sometimes depending on the scenario. Okay. So let's look at this first one. We've got x squared plus y equals 8 and x minus 2y equals negative 6. We should recognize what types of graphs those give me. The second equation, what kind of graph are you going to get for that one? A line, right? If we solve this one for y, you'd have y equals negative x squared plus 8. And what kind of a graph do you get out of that? Parabola, right? Which way is it opening, up or down? Down because of the negative on the x squared, right? You can probably also guess that from the picture that I gave you too, right? Okay. But this graph, the graph of the first equation is this parabola here, crosses the y-axis at 8 and is opening down, right? The other one's a line. It happens to be that line there. Notice that if we're looking for the solution to the system, we're looking for where those graphs cross each other. So looking at the picture here, how many solutions do you think we're going to get? Two, right? That's different than systems of linear equations. Remember, systems of linear equations, there's only 3 possibilities. What are they? For number of solutions? There's infinitely many or one or none, right? Could be no solutions, one solution, or infinitely many, right? For linear. These are non-linear systems. Basically, all bets are off. Okay? You can get multiple solutions. Okay? All right, so let's talk about how we solve these. Again, we could use either substitution or elimination. Since I already solved that first equation for y, I'm going to use a substitution. I'm going to take this. This is what Hope talked about, right? Okay. I'm going to take this and I'm going to plug it in for the y here, right, into the second equation. So that x minus 2 times negative x squared plus 8 equals negative 6. This is substitution method, right? Use one equation to solve for one of the variables. Take that and plug it into the second equation and then solve, right? Okay. What do we need to do to solve this equation? Let's distribute the negative 2. So multiply the negative 2 through, you'll get a positive 2x squared and a minus 16. Now we have a quadratic equation. When we solve quadratic equations, what do we want to do? Set it equal to 0 and factor if we can, right? Let's add the 6 to the other side. We have 2x squared plus x minus 10 equals 0. If you don't see how to factor it, what can you always use? Quadratic formula. This one does factor, though. I need to end up with a plus x in the middle. I got to multiply to negative 10, so that's going to tell me I'm going to have a one plus and one minus, right? I think if I use a plus 5 here and a minus 2 here, it'll work. You can use your AC method if you need to. Again, don't spend a ton of time trying to factor if you don't see how it factors right away. Just use your quadratic formula. Quadratic formula always works, right? But notice in this case, I've got a plus 5x for my inside part and a minus 4x when I multiply that out, right? Plus 5 minus 4 will give me a positive 1x. You can always use your AC method if you need to. That's okay too. Set each piece equal to 0. The first one will give you negative 5 halves because I need to subtract 5 and then divide by 2. And the other one will give us a positive 2 when I'm done. And that kind of matches up with what we see here on the graph, doesn't it? If I kind of go down to my x-axis, that looks like negative 5 halves there. That looks like 2 there. But do I just want the x's? No, I want the x's and the y's, right? We're looking for the solution to the system, right? So I need the x and the y. How do you think we can find those? Plug in the x values into either of the, plug in the x values into either of the equations. I'm going to use this one because I already have it solved for y, don't I? All right. So if x equals negative 5 halves, you would have y equals the negative of negative 5 halves squared plus 8. Pardon me. Sorry. When I square negative 5 halves, we'll get positive 25 over 4, but I got a negative out in front. So it's negative 25 over 4 plus 32 over 4. 7/4? Good. So what I got when I was just going through it, I get 7/4. And then the other one, you plug in 2. We have y equals the negative 2 squared plus 8. 2 squared is 4, but it's negative, so we get negative 4 plus 8 gives us 4. So in this case, we get 2 solutions. So one point is negative 5 halves 7/4. And the other point is 2 4. What are your questions on that one? This really is going back basically to the beginning of the chapter, right? Really going back to the beginning of the chapter. My goodness, sorry. You're going to use substitution or elimination, depending on, again, the context of the problem. Okay? One or the other. Figure out what one variable is, get those answers, plug those back in, and get the corresponding value of the other one. It's just that we're typically going to get multiple solutions as opposed to just one. Yes? This part? So when I square the negative 5 halves, you get 25 over positive 25 over 4. But it's negative out in front. So it's a negative 25 over 4 plus 32 over 4. 8 is the same thing as that multiplied by 4 over 4. Oh, yeah. All right. What do you think about the next one? What method do you think we might want to use? Substitution or elimination? Probably substitution, because I already noticed it's already solved for y here, isn't it? So what do you want to do? We'll take that 2x and plug it in for the y here, right? Now you have to be careful if you make sure you square the whole thing, right? That's x squared plus 2x the whole thing squared, right? Equals 25 when you do the substitution. So when you square that, what do you get? Yeah, you get 4x squared, right? So I'll have 5x squareds on the left-hand side. This one's probably just as easy to divide by both sides by 5. So you get x squared equals 5. What do we want to do to get x by itself? Square root. Remember, when you do square root, you always get plus or minus, right? So we'll get plus or minus the square root of 5 for that one. So those are the x values, right? Positive square root of 5, negative square root of 5. So we also need to find out the y values associated with each of those. So if I have x equals negative square root of 5, what's the y value associated with it? How do I find it? What do I do with the negative root 5? Yeah, plug it in for x and that y equals 2x, right? I have y equals 2 times negative root 5, or just negative 2 root 5. The other one's just going to be the positive, isn't it? So the solutions are what? What's one solution? Negative root 5, negative 2 root 5, and the other one is root 5 and 2 root 5. Yeah, exactly. So we get two solutions again. Again, this one, pardon me, maybe not too surprising that we got two solutions again. Does anybody know what the graph of x squared plus y squared equals 25 is? Kind of a shape that is? It would be a parabola if that y weren't squared, right? This one actually turns out to be a circle. X squared plus y squared equals 25 gives you a circle. And as a matter of fact, the square root of this number here tells you the radius. So you get a circle of radius 5 here. And the other equation's a line. Do you see the two solutions now? The 2 points of intersection? Yeah, so. All right. Work on the next one for a minute and see if you can work through that one, and then we'll chat about it. Solve for x. Solve for x? Good. That's what I would have solved for too, right? Because it's easy just to add the y over to the other side, right? So you have x equals y plus 4. Good. Good. We plug that in for x into the second equation, right? So you'd have y plus 4 times the y equals 12. Next. Yeah, distribute. Good. So what do you get when you distribute? Y squared plus 4y equals the 12. What kind of equation do we have now? Quadratic. So what should we do? Good. Subtract the 12 over. This one should factor. I did plus 6 and minus 2. Good. Yeah, y plus 6 and y minus 2. So your two solutions for y are negative 6 and positive 2. So now we want the corresponding values of x for those two y values, right? Plug it in for y. X equals negative 6 plus 4. So the x is equal to negative 2 for the first one. And the second one, you'd have 2 plus 4, which gives you 6. Right? So what are your two solutions looking at that? And negative 2, negative 6 was 1, and the other one's going to be 6, 2. Good. Bless you. Questions on that one? It's okay? All right. Let's look at the next one. The next one says solve using substitution. So again, same premise here. Solve for one variable in terms of the other, and then substitute back in again, right? Well, which variable? And notice you don't actually have to solve all the way down for x or y. If you're able to get like an x squared equals something or a y squared equals something, you can substitute in. Which equation and which variable do you want to solve for? Yeah, I would probably use the second one and solve for x squared because I can just add over, right? Okay. This one is x squared equals y squared plus 1. But I don't need to worry about square root or anything here because I have x squared right here, don't I? So I can just take this expression and plug it in for the whole x squared. So you'd have y squared plus 1, and then plus a y squared equals 9. Right? Add my y squareds. I have 2y equals 8. If I divide by 2, we have y squared equals 4. So what does your y have to be here? Bless you. It'll be a 2 or negative 2, right? Don't forget, if you do the square root of both sides, you get plus or minus. We're doing a square root method here. You could have also subtracted the 4 over and did a difference of squares to factor it. So far, so good? Now, for each of these, I need to plug it in to the equation that we found, right? So I need to take the y equals negative 2, plug it in, take the y equals 2 and plug it in. If I put negative 2 in for y, I've got x squared equals negative 2 squared plus 1. X squared equals, well, negative 2 squared is 4 plus 1 gives me a 5. So what does x have to equal? Maybe plus or minus square root of 5, right? Right? So notice that for this one y value, we have two x values associated with it. I think you're going to get the same thing for the other one. X squared equals 2 squared plus 1. X squared equals 5. X equals plus or minus square root of 5. So for this one, what are your solutions? How many solutions do you get? You get 4 of them, right? For this y value, there are 2 x's, and for this y value, there are 2 x's, right? So the first one would be positive root 5 comma negative 2, negative root 5 comma negative 2. And the other one is positive root 5, positive 2, and negative root 5, positive 2. So in this case, we get 4 solutions. Is that okay? Questions on that at all? Now, let's go back to the original problem, and we'll do the other examples here. I'm not going to redo this whole thing. We chose to use substitution because the problem said solve using substitution, right? Do you see what you could have done otherwise and done an elimination, perhaps? What could you do to the two equations easily and get rid of one of the variables? Yeah, we could add, right? I can just add down and the y squareds go away, don't they? So you could have also done this through elimination. Just add the two equations, the y squareds go away, right? You would have ended up with x squared plus x squared is a 2x equals 10, or x squared equals 5, right? You would have ended up with plus or minus square root of 5 for the x's. Okay. So you could have also done that with elimination. So in some of these, you get a choice of what you want to do. So let's look at the next example. In this case, the first equation gives you that downward facing parabola. The next one is an x cubed. Remember, just to kind of review a little bit again, remember when you have an odd degree, you either go from lower left to upper right or upper left to lower right, right? And then what tells you is if it's a positive or a negative on there. This one's positive, so that's why it went from lower left to upper right. Okay. Notice we got 1, 2 here. They're going to cross again down here. The graph's cut off. They're going to get 3 crossing points here. But let's see if we can illustrate elimination again. Do you see something easy that you can do with the equations and make one of the variables go away? Yeah, the y's again here, right? I can add those two things together and the y's go away, right? So if you take your x squared plus y equals 0 and your x cubed minus 2x minus y equals 0 and add, what do we end up with when we add? You got an x cubed, got a minus 2x there and a plus x squared there, don't I? There's not like terms there, so they don't combine. But the y's definitely go away, don't they? And it's set equal to 0. So what do we want to do on the left-hand side? Probably. Yeah, we want to factor an x out. I've left with x squared. I'm going to just rearrange some things. I got an x squared, a plus x, and a minus 2. I just flip-flop the last two terms around just so they're going descending order. Do you see how that factors now? How does that factor? Yeah, plus 2 and a minus 1. So what are your 3 x's that you get? Good. So you get x equal to 0, or x equals negative 2, or x equals 1. What do we do with those now? Find the y's to go along with them. Which equation might you want to plug that into? The top one or the bottom one, do you think? I'd probably do the top one, yeah. So if I have x equals 0, I get 0 squared plus y equals 0. It just tells me y is equal to 0, right? If x is negative 2, negative 2 squared plus y equals 0. 4 plus y equals 0, so y is negative 4. The last one, I'd have 1 squared plus y equals 0, and I think you'll get negative 1 for that one. So you should get 3 solutions here. You've got 0, 0, negative 2, negative 4, and 1, negative 1. Like I said, it was cut off down here. If it goes a little bit farther, you would see that they would cross down here at negative 4. But I see the crossing point there and the crossing point there. Everyone okay? Work on the next one for a minute, and then we'll chat about it. Pardon me. The x or the y? The y, right? In particular, I've got x squareds and I got x's. That's going to be really, really hard to try to eliminate, right? In order to be able to add the equations and make the y's go away, I need to have opposite signs, right? So multiply the second equation by negative 1 first. Basically distribute a negative 1 through everything, right? So I'd have a negative y, a negative 2x, and a minus 16. And now when we add down, the y's will go away. What are we left with on the right-hand side here? You got minus 2x plus an 8x. And if we combine, say, we get a plus 6x and a minus 16. Does that factor? Yeah. What does it how can we factor it? X. Yeah, plus 8 and a minus 2. Yeah, good. So x is negative 8 and 2. And then again, we'll take these and plug them back into one of the two equations. Does not matter which. You should get the same answer in either one, right? Just for something different, let's plug it into the second one. Y equals 2 times negative 8 plus 16 gives me 0. The next one, y equals 2 times 2 plus 16 gives me 20. So the two solutions here would be what? Get negative 8, 0, 220. Yep, good. This one okay? Happy with that one? So happy. Sounds like you're thrilled. Very happy. All right. Let's look at the next one. Let's do elimination here again. So we've got x to the fourth plus y cubed equals 17, and 3x to the fourth plus 5y cubed equals 53. Do you want to eliminate the x or do you want to eliminate the y? Doesn't matter. You just have to pick one in this case. Which one would you like to eliminate? X? Okay. So again, in order to eliminate the x, we want to make sure we have opposite signs here, right? What do we need to do to make sure that we have opposite signs so that we can add and make it go away? Multiply by negative. I do agree with the negative, but I need to make sure my coefficients also match, right? Negative 3, right? Multiply that top equation by negative 3. So we'll get negative 3x to the fourth minus 3y cubed equals negative 51. Is that right? Okay. 3x to the fourth plus 5y cubed equals 53 for the other one. We add down. X's go away. How many y cubes do you have? 2. Negative 51 plus 53 gives me 2. Divide, get a y cubed equals 1. Cube root both sides, and you get. And so let's be a little bit careful. Do I need to worry about a plus or minus when I do a cube root? No, just cube root of both sides gives me just a 1, right? Okay. What do I do with that now? Plug it into. The top one's probably the easier of the two. So x to the fourth plus 1 equals 17. 1 cubed is 1. So subtract it over, we get x to the fourth equals 16. Now, in this step, we took the cube root, right? Because we had a cube third power. This one we want to do a fourth root, right? Do I need to worry about plus or minus when I do fourth root? Yes. Yeah. Every time I do an even root, you always get a plus or a minus, right? Odd roots, no. Even roots, yes. So this will give me x equals plus or minus. Fourth root of 16 is 2. Good. So how many solutions are we going to get? 2. What are they? In negative 2, 1, and 2, 1. Yeah. Make sure you put your x in first and your y in second, right? That one okay? Yeah. Okay. Well, let's look at this last one here. I know, I put a log in here, didn't I? That was not very nice. Okay. Try to do a little bit of review for final before we get there. Okay. All right, let's do elimination. What can we easily do in this case and make one of these things go away? Yeah, just add, right? The log, if I add, the log y's go away, don't I? Okay. So add down. I'll just write it out this way. Log x plus log y equals 3/2. 2 log x minus log y equals 0. Add down. We get 3 log x equals 3/2, right? You agree with that? Divide both sides by 3. We'll get 1/2 on the other side. Yep. Okay. All right. So to get now x by itself, we need to remember how to rewrite this equation, right? When you write log with no base at all, what base do we assume? 10, right? So how do you rewrite this equation then in equivalent exponential form? Good, 10 to the 1/2 equals x, right? And then a 1/2 power tells you to do what? Square root. Good, good. So x is square root of 10, right? Okay, so that's the x value. We also need the y value. Right? We also need the y value. Now, it's probably a little bit easier to do your substitution back, not all the way back to here, but look at this. I've got log x equals 1/2, right? I can just plug that into the first equation and replace the whole log x with 1/2, right? So I have, if x is equal to root 10, we would have 1/2 plus log y. Pardon me. Pardon me, goodness. Log y equals 3/2. Right? Because again, I'm using this here. It says log x equals 1/2. So I'm just sort of taking out the log x and putting in 1/2. Right? Okay. Subtract your 1/2, you get log y equals 1. So what does y have to equal? Yeah, 10. 10 to the first is just a 10, right? Doing that equivalent exponential form again, right? Here, I subtracted 1/2 over. Okay. 3/2 minus 1/2 is 2/2. Okay. Right. Yeah. All right. So what's your solution then at this point? Yeah, root 10, 10. Good. Exactly right. This one okay? Yeah. Happy with that? All right. Let's see if we can do one of these examples here. Says the perimeter of a rectangle is supposed to be 70, and its diagonal is supposed to have length 25, and that's to find the length and the width. All right, so let's just draw some rectangle here. I don't know the length and I don't know the width. I'll just use an x and a y to start with. Perimeter is 70. What equation can you come up with from that? Good. Perimeter, remember again, is all the way around the rectangle, right? So we'd have 2x plus 2y equals 70. Diagonal is 25. Well, here's the diagonal. Well, it's one way to draw the diagonal. I could do the other one as well, all right? Just put the y over here. What kind of a triangle did we form with the diagonal here? It's a right triangle, right? What's probably the most famous theorem you know about right triangles? The Pythagorean, right? What does Pythagorean theorem say again? Yeah, a squared plus b squared equals c squared, right? A, B, C, if we do that, that's a 25. So what equation can you get from that?
X squared plus y squared.
25, good. So there's our system that we're trying to solve now. All right. There's the system we're trying to solve. Looking at the way the system is set up, do you think you want to attack this using substitution, or do you want to attack it using elimination? I'd probably do substitution, right? Because I don't have things matched up nicely to just add and subtract away, right? Add or subtract away. Okay. We've decided on substitution. Which equation do you think you want to solve for one of the variables in? Do you want to use the first equation or the second one? I'd use the first. Yeah, exactly. Okay. So do you want to solve for x or do you want to solve for y? Okay, we solve for x. So I'd subtract the 2y and then, I divide everything by 2, right? So x would be, I'd get a negative y plus 70, or 70 minus y, whichever way you want to write it. Or not 70, 35. What do we do with that now? Yeah, plug it in for the x in the second equation, right? Negative y plus 35 squared plus y squared equals 25. What should we do next? Yeah, distribute everything, right? So if I distribute, you get a y squared. You'll get a negative 70y. And you'll get, what? 35 times itself.
Yeah, how did you, why is it negative? Yeah, isn't it positive?
Y is what negative?
Why is 70 negative? Aren't we just supposed to be squaring the 35? I was doing it by itself.
You got to multiply by itself, right? And negative y times the 35 and a negative y times the 35. That's where the minus 70 is coming from. Okay. I appreciate that. What do you get when you take 35 times 35? 1225? It's okay to question me. I'm fine with that. But that one was definitely a negative. All right. So don't forget your extra y squared on the end, and then we have equals 25. What do we do next? Yeah, move everything to one side, right? We've got a quadratic equation again, so we move everything to one side. I've got 2y squared. I've got a minus 70y and a plus 1200. Everything has a 2 in it, so I can factor out a 2. So you get y squared minus 35y plus 600. Yeah. So far, so good. Okay. Hopefully we can factor this. I need a 35. We can't factor, we'll have to use quadratic formula, right? Again, like I said, don't spend all day trying to factor it if it doesn't factor, right? So if you use quadratic formula, what do we have? We have 35 plus or minus square root of negative 35 squared. Ooh. Minus 4 times 600. 2 times 1. So just said a minute ago that 35 squared was 1225. All right. 6 times 400 is too big. It's 2400. Somewhere along the way, something's goofed up, isn't it? Where did I mess up?
When I put them all together, I got negative 1,175.
Say it again.
Negative 1,175.
Underneath the root?
Yes.
Yeah. That's why I know something's wrong, so we should get an answer here. Oh, I know where it is. Oh, shoot. You see it? No? Let's look back up here. Remember how we got this equation here? A squared plus B squared equals C squared. There it was. You should have absolutely questioned me. That should be 625, not just a 25. That's where it went wrong. This is now 600, which makes this 300, which is why it was factoring. I knew it was supposed to factor. Finish this off. My apologies, I forgot to square the 25. 2 times y minus 15 times y minus 20 gives me 0. So you get y is 15 or 20. If you plug each of those in, you'll get your x is either 20 or 15. Which makes sense, right? Because we didn't specify which one was which. We just said x and y, didn't we? So you'll get 15 and 20 or 20 and 15. Those are the same dimensions for the rectangle. So your rectangle should be 15 by 20. You're done. All right. My apologies about forgetting the square down there. That does make a huge difference. All right. Test on Wednesday. Okay. Got reviews posted on Moodle. Hope's got all sorts of hours in there. Hope, you may have to go to the Math Center. I think Dr. Olson meets with her students in the Math Suite. Yep. Unless you're just at the table. All right. Have a good one. We'll see you on Wednesday, if not before.